All right, let's make this fun. Imagine you're working in a food lab, tasting batches of chocolate chip cookies, and your job, figure out which recipe is the best. But here's the twist. How do you actually measure the difference in taste, texture, or even how much people enjoy each cookie? That's where differentiation comes in, not just in math class, but right here, in the world of food. Think of differentiation as a way to measure how fast things are changing. In sensory analysis, that means tracking how a small tweak, like adding more sugar, changes the sweetness people perceive. So let's link this to food security. Imagine you're trying to create the perfect bread recipe in a food-insecure area, and every ingredient counts. You want the bread to be tasty, but you also need to use resources wisely. If you plot how satisfaction changes as you adjust sugar, the slope of that graph at any point is the derivative. It tells you, is adding another spoonful of sugar making a big difference or just a tiny one? Here's where my interactive simulation comes in. Picture a slider labeled sugar content. As you move it, a graph updates in real time, showing satisfaction scores rising and falling. You'll see the derivative, the slope, change as you play. Sometimes a small change makes a huge difference, other times it barely moves the needle. That's differentiation at work. So next time you munch on a cookie or slice of bread, remember, math is baked in. Differentiation helps us make smarter, tastier choices, especially when every bite matters. Hit the simulation and see for yourself how calculus makes food better. One tiny tweak at a time.